Welcome to our next unit. It's time to spend a couple weeks being really rational people. Now, of course, you always want to be rational people in terms of common sense and logical, but in this case, when we talk about mathematical rational functions, we're talking a little bit different here. In our case, rational functions have the word ratio in them, and yes, rational functions are those functions that can be written in fraction form. So, if you love fractions, and I know everybody does, that's what we're going to be dealing with. Today we're basically revisiting Algebra 2, and we are going to remember how we multiply, divide, and then add and subtract fractions. But in our case, we are doing it with variables, not fractions that are numbers. That's why they're called rational functions, because they are expressions that are fractions, but they contain variables. Now, just like with ordinary fractions, if I tell you to take 2/9 times 3/8, you know that when you multiply fractions, you are allowed to cross cancel. And in this case, I would end up with a lovely 1/12. We can do the same thing here. If we are multiplying, you may cross cancel. But before you can do that, you have to have all the expression multiplied. I, for example, cannot cancel these c squareds. That's illegal because there's plus signs in the term up here in the top left corner. So we can't do that type of a thing. Instead, we have to get everything turned into forms of multiplication, which means we get to factor these babies. So you simply need to look at and go, okay, what can I factor with the top two? This is going to definitely push your factoring knowledge. And you'll notice, hey, there's a common factor here. So I could pull out a c squared, which would leave me with a c plus 3. And then the bottom, it's already got c plus 5 squared, not really anything we can do to that. The numerator of the second fraction, looking at that, we're going, hey, dude, that's perfect squares. So I can break that down. And of course, the denominator is one term, so there's nothing I can do there. Now I hope, once I reach that point, though, that I can now cross-cancel many items. And since everything is multiplied, you can cancel any numerator with any denominator. So that means I can cancel the c squareds now, legally. I would also notice there are c plus 5s, but since this denominator over here has 2 of them, I'm only canceling, and I'm left with one of them. I don't see any other like terms that I can cancel, so I'm going to be left with c plus 3 times c minus 5 all over a single c plus 5. You do not need to FOIL those back together. You may leave the answer in factored form. So, I always thought these were really fun when I was first learning algebra, because I thought it was fun to cancel all that stuff and get it down to something much smaller. Okay, and just to run a second one by you here, we have, oh no, it's division. How scary. So if I'm going to do a division problem, okay, how do you divide fractions? Hopefully someone out there is yelling, you have to multiply by the reciprocal of the one you're dividing by. So yes, we are taking this second one and flipping it over so that it then becomes a simple multiplication problem. Okay, while I'm rewriting here, though, I want to note that the denominator of this first fraction looks kind of funny. I don't really like the fact that it has the x squared in the back when all my other terms have the x squared in the front. So does anybody remember, how did we make those reverse? Well, of course, we would prefer the x squared up front and positive, so yes, we pulled out a negative, which made the x squared become positive, and it makes the 1 become negative. They simply switch orders. Now, I should be able to factor this. Looks like I'm heading toward a lot of binomials here. And it's just, since I've got 3-term expressions, I know I'm going to unfoil these babies. And if I'm looking at this first one, I might note, well, hey, it's got a 2x squared, so it's definitely got to be a 2x and a 1x. Okay, the question is, do I want 9 and 1 or 3 and 3? Well, I'm thinking that definitely doesn't look like a 9 and 1 situation. Since it's all pluses, they have to be plus. If I check, do outers and inners make 9x, I would have 6x on the outers, 3x on the inners. That would indeed make 9x. So I'm good to go there. On the bottom, yes, 1 is a perfect square, perfect cube, so since that makes that a difference of squares, that's simply our good friend x plus 1 and x minus 1. Moving to the top of the second fraction, well, it's got to be 5x and x again. Has to be 2 and 1. I don't think I want the 2 in the back. That would make 10, so I think I want 2 and 1 in this order. Once again, all plus signs. Check it, do outers and inners. Make 7x, and yes, 5x and 2x do that. So that's good. Oh, wow, this last one. That's kind of big numbers, and there's not a common factor to pull out, so I'm going to have to deal with those big numbers. Okay, it's also time to play it smart, though, folks. They're going to make these simplify. So chances are good that at least one of these factors is going to be something we see in the rest of the problem. So in the rest of the problem, I note that I have something with a 2x. I have something with a 5x. So I probably need to do 5x and 2x, not 10 and 1. Okay, also once again noted on the 6. There's not any 6. There's some 1s out there. Doubt it's 6 and 1, though. It's got to be all pluses. So perhaps I should kind of look around at some of these other factors and go, there's a 2x plus 3, there's a 5x plus 2. That would be my first, just from the fact that they want things to cancel. We know it's all plus signs again. Just using those factors I already see in the problem. That makes 15x and 4x, and hey, wow, there's our 19x. So that does indeed factor down, and now I can simply cancel any numerator with any denominator. So the 5x plus 2's can go. The 2x plus 3's could go. We have, whoops, over there, I guess I didn't see that didn't catch out there. That's a plus 1. So we have an x plus 1. Those can go. And what am I left with? I've got an x plus 3, an x minus 1, and a negative sign. Negative signs on fractions can be on the top or the bottom. Remember, there's no difference between negative 1 over 2 and 1 over negative 2. They will always leave a final answer with a negative in the numerator. So I'm going to choose to transfer that negative to the numerator. Now, I would have to leave it in parentheses like that, or you could also distribute it and make it negative x minus 3 over x minus 1. Both of those would be acceptable answers. I can't honestly tell you I really know which way this book leaves its answers, but either one of those would be okay. All right, that's multiplication and division. And as you recall back from elementary school, while learning to add and subtract is the easiest thing when you first start out, with fractions, addition and subtraction is not the easiest thing. Addition and subtraction is trickier because, let me take you back. If I say add 1/3 plus 2/7, what are you going to have to do it? Yes. It's, oh no, the common denominator, da, da, da. And in this case, the common denominator would be 21. So how do I make those fractions each have a common denominator of 21? Well, I say, the first fraction needs to get multiplied by 7. And so, of course, I multiply the numerator by that, and I get 7. The second fraction needs to get multiplied by 3. And 2 times 3 would make that a 6. And now I can add them together. Note, when you add them together, what do you get? You get 13. Do you add the denominators? Do you add 21 plus 21? No, you get 13 21st. So remember, when you're working this with variables, it's the same thing. You don't add the denominators, you only add the numerators. Now for us, though, it gets a little trickier. I could look at that one and go, oh, 3 and 7, the common denominator is 21. You can't do that so easily. To figure out the common denominator, you first have to find the factors of the denominator to see what you need in your common denominator. Notice this is a plus sign, so there is absolutely no cross-canceling between these fractions. This is not multiplication. So the first thing I'm going to do is I'm going to attempt to factor the m squared minus 4, which would be m plus 2 and m minus 2. And if I attempt to factor the 3m plus 6, I could take out a 3 and be left with m plus 2. Okay. Now I'm going to decide on what is my common denominator. And I'm going to make both fractions have that common denominator. Okay, starting with numbers, coefficients in front. The one fraction has a 3. So since it has a 3, there has to be a 3 in my common denominator. Okay, here's where we mess it up. I see that I need an m plus 2. The question is, do I need m plus 2 once or m plus 2 twice? Okay, it's the most you see in one fraction. There is one m plus 2 in the first fraction. There is one m plus 2 in the second fraction. So you put one of them in your common denominator. You do not put both. Okay, I also see an m minus 2. There's one of those at most, so I will put one of those in my common denominator. Okay, now you go back to your original one and you go, okay, this first fraction, m over m plus 2, m minus 2, what is it missing in my common denominator? Well, it's got the two quantities. The only thing it needs is a 3. So therefore, I need to multiply numerator and denominator times 3, and I'll have 3m. Second fraction, what is it missing in the common denominator? It doesn't have m minus 2. So I'm going to multiply it by m minus 2, distribute that 2, which is going to give me 2m minus 4. Now I have the common denominator, and this is the step people tend to forget. They make the common denominator, then they start trying to cancel things. Why did you make a common denominator? So you could add them together. Okay, when we added our 7/21 and our 6/21 up here, we only added the numerators. We did not change the denominator. So you're going to leave the denominator alone. Do not change it. And you're simply going to add the numerators. When I add the numerators, I'll have 5m minus 4. Now, a lot of times you're done, but you do need to look at it and go, now that I've added it together, could I factor and cancel the numerator to get it to cancel something in the denominator? And in this case, there's no way 5n minus 4 is going to cancel. So that is our solution. Okay, we're going to take a look at one more of these. Addition, subtraction tends to cause a lot more trouble, and I see that I have a subtraction here, which also leaves room for you to mess up negative signs. So once again, I want to subtract them. I need a common denominator. I've got to factor my denominators first to find what's common. Okay, this one's tricky because it could be 6 and 1 that make a 5. It could be 2 and 3. But I see that it's all plus signs, so therefore it's got to be 2 and 3, so that my outers and inners make 5x. And if I come over here to the other one, yes, that's pretty obvious. It's got to be x plus 2 and x plus 2. Now is the part where we have to be careful. We have to make the common denominator. Okay, I see that there are x plus 2's in both. I need an x plus 2. The question is, how many x plus 2's? There's 1 in the first fraction. However, there are 2 x plus 2's in the second fraction. You have to take the most you see in one fraction. Since the most I see is 2, I only do 2, and I'm going to write it as squared. Do not put all 3. The most in one fraction. Okay, and then of course I see 1x plus 3, so I'll need one of those as well. Now that I've done the hard part, I've found the common denominator, I simply need to go ask myself, what is missing in the first fraction? Does it have actually 3 quantities? We need 2x plus 2's, and no, it doesn't. It's missing an x plus 2, so I'm going to take this fraction times x plus 2. I'm going to distribute that in there, which will give me x squared plus 2x. On the second one, what am I missing? Well, it's missing an x plus 3. Okay, now, so do I write 2x plus 6 on top? You can, but you got to remember this is a subtraction sign. I highly recommend that instead of treating it as a minus, this fraction, change it to a plus, and you are now, actually I want to do that in a different color so those of you looking at notes can see this. I'm going to change it to a plus and make that a negative 2. I am distributing negative 2 in there, so I will have negative 2x minus 6. You must carry negative signs through the entire numerator. Okay, then go ahead and add your terms together. Common denominator is not going to change. If I add that together, interestingly, the 2x's are going to cancel, so I'm just going to be left with x squared minus 6. Now, ask yourself, will that factor and cancel? X squared minus 6, that's 2 terms, which means you'd have to factor with perfect squares or perfect cubes. 6 is not a square or a cube, so we're good. We're done with that one right there. Finally then, our capstone problem of the day, which puts all of it together, addition and subtraction with multiplication and division, is those fun things called complex fractions. Complex fractions are when you have a fractions in fraction. I didn't write that right. Let's try that again. Fractions in a fraction. Okay, realize on this one that n plus 5 is like saying it's over 1. So you have a fraction, 2 fractions subtracted on top, you got 2 fractions subtracted on bottom. The question is, you have a division problem as well. So should I flip it over and multiply, or do I need common denominators first? Okay, you can never multiply by the reciprocal when you have it as 2 separate fractions. This denominator is 2 separate pieces. It has to be all one fraction before you can flip it. So in this case, you must make common denominators first. Then you can flip and see what you can cancel. So we are about to make common denominators here. Notice the common denominator you make on the top fractions does not have to be the same as the common denominator in the bottom. So for those top 2 fractions, what common denominator can I make? Well, sure, it's just going to be n plus 1. Okay, which means the first fraction is missing the n plus 1. And consequently, I'll need to FOIL those together. If I FOIL those together, I will have n squared plus 6n plus 5. The second fraction has the common denominator, so it's just going to stay 12. Now, I'm going to go ahead and finish this one out because this is the mistake I can't get people to do on complex fractions. They make the common denominator, then they try to cancel things. The whole point was to add them together. Get that in one fraction. You must get it put together in one fraction. So that's going to give us n squared plus 6n minus 7, because the 5 minus 12 will make a 7. Okay. Numerator done. Denominator, it's like a whole separate problem. Forget the numerator for a while. What is the common denominator? And here's the question of the day. Are you allowed to do this to make a common denominator? Can I go, oh, it needs a plus 1, add a plus 1. Am I allowed to make common denominators by adding a number or a variable? Answer would be absolutely not. You can never make common denominators by adding anything. That's so illegal. The math police will throw away the key, lock you up. You'll be in prison for life. You cannot do that. Instead, you have to make a common denominator as 2 separate terms. N is different than n plus 1, so this common denominator is both of those. Okay, so back to the beginning. What is the first fraction missing in the common denominator? The first fraction is missing the n. So I'm taking it times n. That's not going to write so good. On top and bottom. Okay, so I'm distributing that, and that's going to give me n squared plus 9n. The second fraction, what is it missing? It's missing the n plus 1 quantity. Now, what do I do with the negative sign? Do I leave it between? If it's me, no way. I don't leave it between. I change that to a plus, make that a negative 5. I am distributing negative 5. So that's going to be a negative 5n and a negative 5. Do everything you can to avoid making negative sign mistakes. Okay, now once again, the whole purpose was to add the fractions together. So you got the common denominator. We need to add the fractions together, which will give us n squared plus 4n minus 5. All right. We're halfway there, maybe 2/3. Because now we have to divide the two. But now it is a single fraction divided by a single fraction. Now it is legal to flip it over and multiply by the reciprocal. So I'm going to flip that over, multiply by n times n plus 1 on top, n squared plus 4n minus 5 on the bottom. Okay, now it's a multiplication problem. Now we can cross cancel once we get these babies factored. So I need to ask myself, how could I factor this? Well, this one's got to be, it's trinomial, it's got to be, unfoil it. It's got to be 7 and 1. We want to make a positive 6, so it must be a plus 7 and a minus 1. That wasn't too bad. Okay, second one, we're going to leave the n and n plus 1 alone on the numerator. Denominator also has to be a 5 and a 1, no choices otherwise. We need a positive 4, so it must be plus 5 minus 1. Okay, then finally, ask yourself, what can I cancel? This is the fun part. N plus 1s go. N minus 1s go. Can I cancel n, that single n? No, you have to cancel whole quantities. You can't cancel individual terms. So looks like I'm pretty stuck. And I'm finally going to be left with, then, an n times an n plus 7 over an n plus 5. And considering where I started, that looks pretty simple. A whole lot better than what we've had before. So, there you go. You've simplified a complex fraction. Key thing is, write neatly, keep it organized, don't try to do too many things in one step so that you mess it up. I always have people who don't want to use extra lines of their paper, who cram it up, try to put too many things on one line, and then they can't tell what they're doing. Enjoy. This is just good old basic fun algebra.